All right, now that we are past the introduction, um, and before we actually dive into the nitty gritty of the experiments you'll be performing today, let's do some hypotheses. So, in the first experiment, you're going to see how allele frequencies change due to genetic drift after 100 generations. So, again, you're going to see you've got this population of koi, right? These big old goldfish, and they're about equal. You've got about equal numbers of orange ones, equal numbers of white ones, and equal numbers of white with orange spots, right? So what we want to see is how will that change after 100 generations of the breeding? How will it change, right? And again, we're talking about genetic drift. So genetic drift is all about change, or excuse me, chance. No, excuse me. Um, so there's no migration, right? There's no kois coming in. There's no kois leaving. There's no mutations, right? So all these alleles are going to stay the same as far as that's concerned. They're not going to mutate to any new alleles. There's no natural selection because there is no advantage of being white over orange or perhaps white with orange spots, right? There's no advantage to that. There's also no sexual selection, right? So being white, for example, is not more attractive than being orange. So there is no reason, so to speak, in a way, where you would expect anything to change, right? So that's what genetic drift is, right? So changes by chance. So again, we're going to look at this population. They're going to breed for 100 generations, and we're going to see how they change. So the question is, how do you think the allele frequencies will change due to the genetic drift after 100 generations? So it says underline your choice. I don't care how you do it. Maybe if you want, you can erase the other choices, or you can make it bold. I don't care how you do it, right? As long as I can somehow tell what your choice is. But anyway, the choices are, you're going to think maybe there's going to be increase of whitefish, or an increase of orange fish, or an increase with orange fish with white spots, or maybe there'll be no change at all, right? And those are your four choices. So choose one of those, underline it. And to be honest with you, again, I don't care. You can underline it, bold it, as long as I know what your choice is. And if you want, even, you can just erase all those and write your own hypothesis. Because if you want to, you can be really specific and say, I think at the end there'll be many, many more orange fish and very few white fish, or I think it'll change a little bit, but not much. And I'm not sure which one will change, right? I don't care. Basically, I want you to come up with a hypothesis, and I've given you these four as an option, as options to choose from. And if you want to come up with your own, that's fine. So really the question is, how do you think the population is going to change, right? Between the oranges, the whites, and the orange with white spots, how do you think it's going to change due to genetic drift over 100 generations? In the second experiment you do, it's the same thing. You're still going to be looking at the same original population. You're going to watch them over 100 generations, and we're going to see how are they going to change. But in this case, we're talking about gene flow. So we're not talking about genetic drift. Now there actually is something that will be changing the population. Specifically, you're going to have more individuals coming into the population that have a big R, right? So you're going to have fish coming in. There'll be some big R's, there'll be some small R's, but overall, you're going to have more big R's than small R's. So then the question is, after 100 generations, how do you think it will change? And again, just like the last one, somehow, I've given you these four to choose from. So somehow indicate which four that you choose, whether the white fish will increase, the orange fish will increase, or the orange fish with white spots will increase, or there's no change, right? Those are your choices. Choose from those if you want, or if you have some other hypothesis, again, you can write that down too. For experiment 3, same thing. We're starting with the same original population of fish. We're still going to watch them for 100 generations. But in this case, we're looking at change due to mutation. And we don't know what the mutation could be, right? Because you don't know what mutations are going to be. They are random. So again, the question is, how do you think the allele frequencies are going to change? How is the population going to change after 100 generations? How will mutation change the population? Same thing here, right? I've given you these four choices. Indicate which one you think. Are they going to be more white fish? Are they going to be more orange fish? Are they going to be more orange with white spots? Or maybe there won't be any change at all. Again, those are your 4 choices. Indicate which one you choose, or again, write your own. Finally, in experiment 4, we are going to see how we're starting again with the same original fish population. And again, we're going to watch them for 100 generations, right, as they keep on breeding. And we're going to see how natural selection changes it. And in this case, being white has an advantage over being orange, right? So in this case, white is advantageous. Orange is like, it's kind of bad. And the orange with white spots is basically neutral. So in a sense, you could think of, if this was a real life situation, you can imagine maybe maybe there was a change in the environment, and now the pond is mostly white colored. Maybe now the pond is in marble, or it's covered in snow. Or for whatever reason, let's assume things went white, and because of that, maybe these white fish have a better chance of hiding from the predators, and maybe these orange fish, right, the big R, maybe they just can't hide at all from the predators, so it's lethal. And again, these the white with orange spots is neutral. So anyway, that's the situation. You're going to start with the same original population. We're going to watch them breed for 100 generations, and the question is, how do you think it's going to change over 100 generations? You've got the same 4 choices to choose from. Do you think white fish will increase? Do you think the orange fish will increase? Do you think the white or orange with white spots will increase? Or do you think there'll be no change at all? So choose one of those 4, make it obvious which one your 4 choices are. And again, like the other ones, if you have your own hypothesis, you can also write that there. So that is the end of this video, in which we talk about hypotheses. And the next video will be all about how to actually do the experiments and how to record your data.